Hello, welcome back to Learn Economia. Here we discuss the economics of climate change. There are necessary precursors to regulating greenhouse gas emissions under Clean Air Act. It is very important to understand that. Uh, it is identified that there have been various greenhouse gases. Out of them, six are very much poisonous, very much dangerous. These include carbon dioxide, methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. Okay, and these are considered to be endangering the public health as well as the welfare of current and future generations. It could be found that emissions of these six greenhouse gases from motor vehicles would cause, or this would contribute to greenhouse gas pollution, which would endanger the public health as well as welfare. Sorry. Areas of climate economics. Or the research in the areas of climate economics include economic analysis of regulatory policy instruments such as emission trading, estimation of greenhouse gas reduction, uh, role of uncertainty, modeling the economic impacts of ocean acidification, etc. How could we regulate emission? There have been two views, prescriptive versus market-based approaches. Since 2007, since 2007 Supreme Court ruling, which concluded that CO2 and other greenhouse gases are pollutants, debates over policy approaches to addressing climate change has intensified, especially in the United States. A number of theoretical as well as empirical studies have shown important advantages of market-oriented policies over command and control approaches to controlling pollution. Specific market-oriented approaches that are often discussed by different economists as a way to reduce greenhouse gas emissions. And these include, first of all, tradable permits. We have already done a video regarding tradable pollution permits. I'll be providing the link of the same in the description box. If you have not watched that video, please go and watch, because that would give you a good understanding, a good in the sense, a very better understanding regarding the tradable pollution permits aspect. So this program sets a specific target or cap on total emissions and allocates or auctions the necessary number of pollution permits or allowances to polluters to meet the goal. Polluters that are able to reduce their emissions more cost effectively have an incentive to abate more in order to avoid purchasing allowances or to sell their excess emission allowances to polluters facing higher cost of compliance. Under this type of market-oriented approach, emissions are set by the cap, but the overall compliance cost might be uncertain. Then we have emission taxes, like this pollution permit, which are tradable. Tax-based regulatory systems provide incentive for polluters to find cost-effective solutions to emission control. Firms will either pay the tax, or if it is cheaper, they will reduce emissions to avoid the tax. In the case of emission taxes, the cost of compliance is known, but emission levels might be uncertain. The primary regulatory advantage of a market-oriented approach is that it can achieve particular emission target at a lower social cost than a more prescriptive regulatory approach due to greater flexibility that it offers sources in determining how to reduce emissions. Or you could say that market-oriented approach leave the method for reducing pollution to the emitter. In these kinds of cases, emitters have an incentive to find the least cost way of achieving regulatory requirement. More precisely, we could see that more prescriptive regulatory policies typically restrict emitter choices with regard to how they reduce pollution. In part, it is inflexibility that leads to a higher cost of controlling pollution. Furthermore, market-oriented approaches create a single price for emissions, either through the tax on emissions or price of a tradable right to emit. That is common to all the polluters in the economy. Given this common price for emissions, the total abatement required by policy is distributed across all emitters in such a way that the cost of reducing emissions is minimized. Here, polluters with the lowest control cost are those that abate the most. By leaving the method of reducing pollution to emitter, market-oriented approaches provide a greater incentive to develop new ways to reduce pollution. Polluters not only have an incentive to find the least cost way in order to adhere to the standard, they also have an incentive to continually reduce emissions beyond what is needed to comply with the standard. For every unit of emission they reduce under a market-oriented policy, they either have a lower tax burden, must purchase fewer permits at auctions, or they can sell the permit. Market-oriented approaches are well suited to controlling greenhouse gas emissions, mainly because a unit of greenhouse gas emission has the same effect on environmental quality regardless of where it has occurred. Also, while policies can control the flow of emissions, what is ultimate concern is the stock, the concentration of cumulative greenhouse gas in the atmosphere. In the short term, you could see that this means that damages per additional ton emitted into atmosphere change little with the amount emitted. These two characteristics imply that it is less important to regulate the exact location and timing of emission reductions that are often the focus of the typical regulatory approach. Increased flexibility in how, what, and when sources reduce greenhouse gas emission does not have much effect on benefits from reducing them, but can greatly influence the cost. If certain sources are exempted from policy, then some relatively low-cost emission reductions might occur, raising the overall cost of the policy. If sources of pollution are compartmentalized into different sector-specific or pollutant-specific approaches, each class of polluter might face a different price for their contribution. Contribution to the environmental harm they have done, and therefore trading opportunities that reduce pollution control costs would be unrealized. Also relevant to decision makers is how the cost of a market-oriented climate policy would be distributed across households with different consumption patterns and levels of wealth. Households are affected by both the stringency of policy and how potential allowance value or emission tax or emission revenue is distributed. The way that allowance or tax revenue are distributed can affect the overall cost of policy. For example, allocating allowance value based on the amount of electricity a household consumes is generally progressive because low-income households spend a larger percentage of their income on electricity than higher-income households. However, this effect subsidizes electricity consumption and in turn makes it more expensive overall for the economy to achieve the desired carbon emission reduction since it must look for those reductions elsewhere. We can see that the tradable permit systems have been the most widely used method for regulating the greenhouse gas emission. The most comprehensive cap and trade scheme currently which is in operation is the European Union's emission trading scheme. This has initiated to help the European Union member states to comply with their Kyoto Protocol targets. I hope everyone is familiar with Kyoto Protocol. EU emission trading scheme allows use of offset. An offset is an emission reduction from a source outside the cap in place of reduction from a regulated source. Other examples other than coal-fired power plant. This include improving livestock management to reduce methane emissions. In the case of coal-fired power plant, you will see that purchase offsets from a landowner who sequesters carbon by reforesting grazing land instead of installing technology in order to reduce smokestack emissions. Extending the market-based incentive of cap and trade programs to regulated sectors and countries to offset offers advantages by increasing flexibility and decreasing cost to meet emissions target. Challenges to design credible offset programs include additionality, leakage, permanence, etc. What are the challenges in estimating costs and benefits of greenhouse gas policy? It's a long time horizon over which benefits and costs of climate change policy would accrue, and global relationship they involve raise challenges for estimation. The exact benefit and cost of virtually every environment regulation are at least somewhat uncertain. It is very difficult to calculate. Estimating benefits and costs involve projections of future economic activity and future effects, cost of reducing environmental harm. In almost every case, you can see that some of the future effects and costs are not entirely known, or this is very difficult to quantify or monetize. In each of this case, especially in the case of climate change and all, uncertainty inherent to economic analysis of environmental regulations is magnified by long-term and global scale of the problem. There are uncertainties regarding pace and form of future technological innovation, economic growth, thresholds for climatic impacts, etc. These difficulties in predicting the future could be addressed to some extent by evaluating alternative scenarios. Even with these kind of uncertainties, there is a rich literature which would attempt to estimate the social cost of carbon. The social cost of carbon reflect the changes in agriculture productivity, human health, property damages as a result of increased risk caused by flood, etc. In 2010, an interagency working group produced original estimate of this social cost of carbon, and we could see that the purpose was to estimate the possible benefits from reducing CO2 emissions into cost effect or cost benefit analysis of regulatory auctions. In 2030, the intra-agency working group produced a technical update that leaves all the intra-agency assumptions and that has unchanged, but updates to the latest version of each of the three integrated assessment models used to estimate the social cost of carbon. The intra-agency working group has committed itself to updating these estimates as science and economic understanding of climate change and its impact on society improves over time. Now coming to ocean acidification. In addition to the impacts of climate change, the increasing levels of carbon dioxide in the atmosphere are contributing to another devastating process which is known as the ocean acidification. Oceans are largest carbon sinks on Earth, absorbing nearly 1/3 of anthropogenic carbon dioxide emissions. The altered chemistry of the ocean will affect the ability of some marine organisms to form their shells, skeletons, etc. Projections of impact vary across marine species, region, CO2 emission forecast, etc. The first noticeable impact will probably be considered to be widespread loss of coral reefs. In the last time, you could see that the atmospheric concentration of CO2 reached projected levels. Coral reefs, many have disappeared from the fossil for the record for 1 million years. Climate change and ocean acidification these are closely linked. For example, the damages to coral reefs from ocean acidification can be considered to be kind of coral bleaching which is being caused by warmer ocean waters. These same coral reefs act as buffers to tropical storms that are expected to increase the frequency and severity as a result of climate change. And because reducing the atmospheric concentration of CO2, this is considered to be a way to mitigate ocean acidification on global scale. Some strategies to combat climate change, for example, those that focus on non-CO2 greenhouse gases could have negligible effects on the acidification of the ocean. So we can see that NCE is conducting researchers is actually a body to analyze the economic impacts of ocean acidification that can be included in the estimates damages from greenhouse gas emissions. And also they participate in cross-office and interagency efforts to guide research in the arena of this ocean acidification and inform the national policy discussion. So that's all. Please like, share and subscribe to this channel for more videos, and thank you for watching.